Okay, so thank you for coming to this talk. I know that we had some other great options, and hopefully it will be worth your time. This is probably the longest title for a presentation that you see in this conference. Apparently I made some mistakes with my cut and paste and ended up writing much more than I expected. The real name is, what do you mean threat model every story? Who has the kind of time? Go away and take your threat model with you. So it's very important for me to say that this is not a scientific work. This is not a quantitative work. I'm not bringing numbers that you can compare with other things. I'm not bringing before and after. This is extremely subjective. Why? Because this is a process that we have started at Autodesk in the past few months. I don't know, 6, 8, or something like that. And we don't have the numbers to stand behind it. But we already have the initial impressions, and we already have some lessons learned of putting the process in place. And that's what I'm trying to share with you guys today. So yeah, don't look for any scientific precision in here, because you're not going to find it. And actually, a lot of what I'm going to put in here is basically my opinion from my experience, so feel free to disagree. So who am I? Right now I am lead security architect at Autodesk. I focus on application security. I have 2 peers that deal with other domains. And before this, I was for about 8 years with EMC. Before that, briefly with IBM. And before that, the whole startup game and whatnot. I pride myself in being a collaborator with SafeCode, and for its brief life, the IEEE Center for Security Design, and worked on threat model material in there. With SafeCode, we have some basic threat modeling training that's available. We have a couple of papers that are really interesting if you're into that kind of thing. And to tell you the truth, I am the guy that always complains, mostly to my friends, but I am mostly complaining. And what brought me forward to try and share something with the wider community of practitioners is the fact that I got tired of complaining. And I started looking for solutions, and I wanted to share those solutions instead of just complaining. So now, for me to calibrate myself, I need to know who you are. So please raise your hand if you threat model every day. You can raise your hand many times. Okay? If you want to add threat modeling to your practice. Oh, that's a better number. If you do research work on threat modeling. Goody. And if you are in the wrong room and you just don't feel like you can go out. Okay, just one. Okay. We're going to pause now so that he can go out. So what am I bringing for you today? First of all, we have to agree, what is this thing, threat modeling? It's going to be brief, because the raised hands show that there is already some understanding here. Then I want to spend some words on what was my personal threat modeling journey. How do I got into this thing, and what did I try up to this time? Then what were the problems that I found while I was going there? And finally, after much complaining, how I'm trying to solve them. And in that how I'm trying to solve it is the proposal of how you could use the same ideas and how you could adapt them to your environment. At the end, we have a tool that is going to be presented to the public for the first time officially. And of course, references of everything that I talk about. So 3 definitions of what threat modeling is up here. The first one is just the one that you take from your pocket and you say, you know what, it's just some exercise that we're going to think about this thing and see if we can figure out what's wrong with it. Then we have something a bit more formal by Brooke Schoenfeld, where you look at the system as a state in a state machine, and you figure out what are those things, those operations that are going to bring it from an unsafe, unsecure state to one where it's secure. And then we have Adam's 4 fundamental questions, which I personally refer to as why is this threat model different from all the other threat models? Okay, and it's better if you get like the youngest child in the team to sing the questions. But it's basically what drives us nowadays. We want to know what is it that we are working on, where could it possibly go wrong, what is it that we have to do so that if it goes, we get out of it well. And then we want to look back and know if we did a good job or not. Now, personally, when I started this whole thing years and years and years ago as a developer, we didn't have this whole security thing going on. What we did have was a community of people who were poking things and making them go down, making them not function, or getting where they were not supposed to. So my first attempt at what could go wrong was very private discussion with myself in terms of, oh, there's this new nifty thing. It's called a buffer overflow. Could that work on my code? Did I make any mistake that could end up in something like that? And slowly build an understanding of where it is that my code was lacking. Now, here, as a developer at that time, I was talking about code. I wasn't talking about systems yet. Then, still as a developer, I found out about Stride and started using it. Now, one very important thing here, I'm just going through a timeline, and there's absolutely no judgment. This is a safe space of which methodology is better than the other. There isn't such a thing, I think. Okay, we're going to see in the next slide something about that, but one is not inherently better than the other. They all have their time and place. They all function in different spaces and teams, and it's important to keep that in mind. But then I figured out strides per element, and that's when I started making my first steps as an architect, and I saw it was good. And then moving to EMC, I found out about threat libraries. And those two were good, and they had their use. And then moving forward, as I got more, with a more close relationship with the teams that I was working with, it came to the point that having a frank conversation with them about the system and actually going down deep rabbit holes was something extremely useful. And then the whole agile thing started, and people wanted to do it more and more and more and more. And I played for a while with threat modeling spikes. Again, I went back and forth into one, used the other, but this is just how I myself, looking back, see me going from a place where I was doing no threat modeling at all to a place where I was doing what I do today. But when I was going through these things and when I was using each one of those systems, what is it that I was looking for? What would be the one thing that would make me think, oh, this thing solves my problem. This thing works the way that I need it to work. I was looking for some separate things. First, if it was accessible, meaning would the team always need someone to lead them? Could they do it after they learn a bit about the methodology? Can they keep doing it? Is it something that's going to sustain itself? It had to be scalable, meaning can many teams do it at the same time? I know that it's probably a situation that's less seen, but for the last years, I've been working in places that have many, many, many product teams at the same time. And not two product teams in the same place work the same way. So I had to find a methodology that I could throw out there, and different teams with different philosophies, different compositions, different cultures could pick up and run with it. Is it educational? There's no point if I'm using a methodology that makes me figure out the things that I want to, but only I know how to do it. There must be some transference of knowledge. The teams have to be able to learn from what they're doing and, again, be able to do it themselves. Is it useful? The findings that come out of it. Can I use that stuff, or is it going to be labeled mostly, I don't know, false positives, false negatives, or something, and the team is going to say, well, I got too many of those, I can't work this way, let's move forward. Is it repeatable? Does it fit into the agile scheme of things that it's not slowing down the team? A team using this thing, are they going to suffer in how much work they can put out or not? And finally, if it was representative. At the end of the day, when I look at the threat model, how close is it to the system that's out there, the system that was actually developed? Oh, and there's also unconstrained. Meaning, is it something that's going to keep the team thinking in terms of this small fence, or are they going to be allowed or even asked to go outside the fence and think outside the parameters that they've been working on? So if again I look back to the things that I use and ask myself, okay, those methods that I chose as milestones of my journey, how do they measure in these parameters? So again, no judgment. It's just a way to compare one with the other in terms of these specific parameters. So Stride, for example, it was definitely giving me a lot in the unconstrained. It let the team, it let the developers think off the fence, go looking for stuff out there, stuff in the business logic, not be constrained to something specific. But on the other hand, it really required an SME, because you fall again into the trap of thinking like a hacker. Not everybody knows how to work with an attack tree. Many times people see a bunch of documentation that come in terms of even an attack tree and look at that and panic because it's just too much. They don't know how to deal with that stuff. So you would more than not need somebody to lead them by the hand. Then Stride per element gave me a bit on the agile scale, and together with that on the representative, because that separation of let's look at one element and see what's more important for that specific element instead of let's look at the whole system and look at everything that can happen with that system, gave a chance to those teams that work in different parts of the system to work more closely, to focus more closely on that thing that they're working at that time. On the other hand, it stays low on the accessible. It stays high on the unconstrained. It might be a bit more scalable because, again, the teams are working separately. And it's as useful as Stride. And then there's the paradigm shift of threat library. Working with a set of threats that were identified in history of that company, organization, product, or not, and looking again, are they happening again? So that one takes a huge hit on the unconstrained, because it's basically giving me a list of things that I want people to look for. And stays in the representative, same thing. A bit more agile, because now it gives the teams something that takes them by the hand, lets them do the things at their own speed, and move forward in their own speed. And it is a bit more educational, because since I'm looking for those specific things, now I have much more control of the amount of material about each one of those that I want to give. So I can assume that once somebody saw that once, they'll be able to deal with it later. And then there is the SME-led, which of course explodes in the unconstrained. You have somebody who lives for that stuff thinking about it. So of course they're going to come up with more stuff. It's accessible, yeah, as long as you have somebody like that around. The team can always make use of them. And of course, because of the constraints of the need to have someone like that around, it's going to be much less scalable and perhaps hit on the agile scale. Okay? So, knowing those things and knowing how those techniques compare, what was it that took me to the case for continuous TM? What made me think, okay, this is something that perhaps makes sense? There is this this tweet by Jim Manico that always comes back to me, and basically makes me think that, you know what, there's something missing here. They are not only security engineers, whether they know, admit, or do it, they are also architects. Because the way that we are developing stuff nowadays, you don't have that big design in the sky that everybody is going to follow. You have that design that's emerging every time that somebody picks up a story and has to decide exactly how they're going to implement, what they're going to use to implement it, and what parts of the system they're going to use. There is much more opportunity for somebody to make a miscalculation and put things in the wrong place, or open the wrong thing, or use the wrong library, and it's much more difficult for us to see. The sentence that's used to translate that for me was by Seymour Cray, of the famous Cray supercomputers. And he used to say that the problem with a programmer is that you can never know what they're doing until it's too late. So With that in mind, and with a lot of my personal, the chip in my shoulder being the kind of training that we give to people. Okay, last year I had a talk here at AppSec Cali that spoke only about that, the way that we are training people for security. In my view, it's almost counterproductive. We are giving them masses of information, but we are not making them sensitive to what is it, when is the right time to use that information. So we are spending a long time telling people everything about the RSA algorithm, but we are not telling them when to use it, what the size of the key should be, how to store it, practical things that actually, when they sit down to write something, nobody wants to start thinking about M, N, P, P minus 1, Q minus 1. That doesn't help anybody, and our CBTs are still spending a lot of time on information at that level, which later on we say, okay, now you're trained, go be secure. And it doesn't really work that way. So, so there is that. So once I got to that epiphany, understanding that the developer is the guy in the line that actually has to be aware of everything that's happening, that's when threat model every story was sort of born. Or at least I started kvetching about it to people, and together with a lot of input from them, started coming out with this thing. So I'm just going to throw it out there, and then I'm going to give you some more background, and we'll go back to it step by step. So start with a baseline. Okay? Don't care what methodology you use, just have a baseline for your threat model. Whatever, if you are starting out the development, if you already have something developed, just get that first threat model out there, something to serve as a baseline. So at Autodesk, we are currently using this subject-based list. We're going to talk more about it a bit later. After you have that baseline, find 1 or 2 or 3 people who are you going to designate threat model curators. Now, those don't have to be the technical heads of your team, the geniuses, the guys that understand security. Those are simply people who are going to mind a couple of queues and make sure that whatever comes through them gets the attention that it needs. Now you go to your developers and you tell them, listen, as part of your definition of done, the things that you are going to do to call a story done, I want you to ask yourself these 2 questions. Does it have any security value? If it doesn't have security value, do your thing, move forward. If it does have security value, then I want you to either fix it, and if you fix it, let us know that there was something there that needed some kind of fix or some kind of special consideration, or pop it up as a threat model candidate finding, meaning this is something that you think should be part of a threat model, and pop it up and let one of those curators know about it. So at Autodesk, for example, we are using this. We are using Jira for this, and we just attach security TM candidate to the tickets. And in the end, of course, make sure that your curators know what's going on and that they are paying attention to that stuff. But now comes the question, going back to that training thing. How do I know that these developers know what has security value? How do they know that something that's a notable security event happened right now? And going again to my rant of training, what about if we listen to that great man, Richard Feynman, who said, teach principles, not formulas. And I'm just going to expand on something that he said on the subject. So he says, do your own homework. To truly use first principles, don't rely on experts or previous work. Approach new problems with the mindset of a novice. Truly understand the fundamental data, assumptions, and reasoning yourself. Be curious. Okay? So basically, the idea here is if we tell someone, okay, you are writing a query against a database, so use this ORM because there is this thing called SQL injection, we are basically teaching a formula. We are saying every time you have a query, you are going to use this thing. Okay? We're not giving them a principle. We're not telling them, hey, there is this thing called injection. It's bad because A, B, C. this is how it works, and I want you to take that into consideration. And that's how we get those cases where the developer comes and says, well, I need a query, but the ORM doesn't cover that, so I'm just going to write pure SQL, and all of a sudden, boom, you have an injection problem in there. Because the consideration of the base of the thing, of what's the badness of the thing that I'm writing, was not taken there. So, at Autodesk right now, we are using these two tools, for lack of a better word. We have the subject areas, and in the subject areas, we use them for the big baseline, for the stuff that we want the whole team to sit down and consider together. So we offer them not a checklist of things to go look for, but we say these are the areas that we are interested in, and we give them a couple of questions here and there that might help direct that. And then for the developer level, we have the checklist. And the checklist, it's, again, we're going to see an example, but it's just looking for the principles. So together with the subject area, we offer a threat modeling handbook. And this is basically the whole handbook. Those are all the things that we are saying. We are saying why you're doing this, when we want you to do it, what it looks like when it's ready. We are giving you a process, methodology to do it using the subject areas. And we are telling you what to do with the findings. That's all. That's the whole process. If at the end of the day you come back to us and you have findings on Jira, they are labeled the right way. You have a threat model that conforms to the output that we asked you, and it's in the right place, you're golden, you're fine. Notice that at no point we checked how many findings you have, what is the goodness of the findings you have. No, we want you to go through the process. We'll deal with the quality of the findings later on. And to lead this project, as I already said a couple of times, we have this subject areas. Now this is just part of the list. I think that all in all we have 18, 19, perhaps 20 subject areas, but this is just the top. So we say, okay, this is the thing that interests us, and if you were going to have this discussion, these are some questions, 2 per subject, that we think you should start from. And then let people have their own process. The beautiful thing here, the beautiful thing actually working with developers, and this is something that I saw almost everywhere, they're extremely, extremely smart people. And yeah?
Is that based on NIST 171?
Sorry?
Is that based on NIST 171?
No. It might be similar. The question if it's based on NIST 171. So I never seen it, so I would say that no. But I'm happy that it goes together with some form of standard. So where was I? Yeah, so developers are extremely curious, and more often than not, they want to do the right thing. So if you point them in the right direction, they will do their exploration by themselves. Now, together with this, another thing that we offer is a Slack channel for people to come and ask questions about this stuff, a Slack channel just for threat modeling. So sometimes you get questions about the process, but sometimes you get questions about what is it that I'm looking for, some interesting problem that they bring to us for consideration. And you see that there was somebody tried to do the hard thing, the right thing in there, and noticed that they did not have enough information or enough understanding or enough tools in their hands, and then they come to us and ask that question. And that's where the interesting stuff lives. So even as a security team, I think that we get a leg up on the fact that we don't have to day-to-day deal with the mundane, simple things. We get to only see those really interesting things. Now, the checklist, the one that we ask the developers to follow, this is what's called the traditional checklist, right? This one specifically is for some part of the flight of the space shuttle. And I can tell you, people would see a checklist like that and despair, go crazy. Like, ask yourself how much background knowledge you have to have in order to understand a checklist like this. Like, the astronauts study for years, and they still have to use the checklist. They still go by the checklist. And sometimes they still have problems figuring out the checklists. So our checklist looks like this. It's a different kind of checklist. It's what's called the if this then that checklist. So it says, if you did this, then do that. And the whole checklist fits in front and back of one page. We are not trying to be exhaustive here. We are trying to teach principles. And when you look at principles of security, you may go back to papers like Salzer and things like that, and you're going to see that there's a very limited number. Of course, if you go and look at a cheat sheet for something specific, you can see huge amounts of things. But those things are switches that you're throwing. Those things are not the thing. They are not the principle. They are not the thing that you're trying to protect. They're not the idea that you're trying to transform into code. Those are merely switches. You are hardening a system. You are basically throwing switches. Okay? So instead of throwing switches, we ask people to ask themselves these questions, and on purpose, they are written in development language, meaning we try to keep away from anything that resembles security domain words, buzzwords, questions, issues, and we kept them here. We kept them on this side. Now, looking at it, we say, okay, you went way too simplistic. One line for something like that is a bit too little. So when we open them up, we go to one paragraph, two at most, with something that serves as a beginning for them to go click away as much as they want. We are not forcing them to consume huge amount of information every time. Now, can anybody guess what's the final purpose of this checklist? It's very simple. It's to stop being used. At some point, we want developers to not have to use it anymore. They will have understood the principles. More than that, they are going to have developed muscle memory to identify when is it that they need to use these things. They'll be able to identify those points in their coding process that says, oh, this has some security value. I should be doing something about this. And eventually, they will even know what the something is, depending on their own environment. So somebody who's doing C, C++ will look at different things from somebody who's writing Java. Things that we don't have to put in front of everybody all the time and expect that some of it rub it off. So looking again at the whole loop of the thing, now with the understanding that we have those supporting things to lead them through the process, I think that this paragraph here, the one about the security notable events, becomes much clearer. Because now we have a framework to tell people these are the events that we're interested in. These are the things that should trigger some kind of action from your side, some kind of awareness from your side. And that's what we want to know when you reach this point. Okay, so let's look at the threat modeling timeline in two situations. Usually, in the best of all amazing worlds, you have this idea for a system. You're going to sit down, do design. At that time, you're going to do your threat modeling, and then you're going to spend a lot of time doing development, but no more threat modeling. In a perfect world, that's all it is. But we don't live in a perfect world. So what we end up with is a lot of work in here to do your first threat model. People come and write their system, write their software in here, and then at the end, you have another huge pike to reconcile between what you have in here and what you actually have in here. So you're basically almost doing the thing all over again. So if we thought about, okay, let's do this continuous threat modeling thing, what the first idea would be, okay, I have these spikes of work. What's going to look like is this. I'll have more effort every time that I do the work. And this would be the immediate reaction of somebody saying, okay, you have to to do more things in the same time that you're already doing things. But this is not what we have observed as we try to put the system in place at Autodesk. What we started seeing is something like this. So if green here is the actual work, I should have put a legend here, I'm sorry. If green is the work being done, the development work being done, and blue or purple is the work being done with the checklist, the work being done doing the continuous threat model at every story, what we see is that it starts with people doing that work right after they implemented their story. It happens a couple of times. Then at some point, it jumps to the front. They start looking at that before they actually implement it. And then after a couple of times, they are doing it while they are implementing it. So yes, there is more work. But because it happens at the right time and it's probably made the right way, it factors out the other work that you would have to do to come and fix everything in the beginning.
It just becomes another design constraint.
Exactly. It becomes one of those things that, one thing that bothers me a lot, I told you guys, I complain a lot. One of the things that bothers me is that developers, they sit down to think, okay, this is what I'm going to do in my next story. And they think about performance all the time, without feeling it, without thinking it. If they look at something that looks like it's not going to perform or it's going to have a bottleneck or something, it jumps to the eye and they feel that feeling that this thing cannot go this way. But nobody has that same feeling of security. Nobody looks at something and says, oh my God, that's going to be insecure. I should not be writing that. And that's where I want them to be. That's where I need them to be. Okay, so the good thing here is that we see the checklist being used after, then being used before, and then going away. I don't think that we have teams that have reached the gone away stage, but I do know that we have people.
So how do you reconcile this with separation of duties? I mean, it's a great principle, but as a matter of fact, you still are responsible for making sure that the threat model actually resembles from the
So that's why you have the curators.
So the curator role, is that technically the same as a regular threat model role at this point?
It's technically the fact that if the curator is sitting down and he sees that there's nothing coming in the queue, probably something is wrong. So it's time to go and check out what people are doing. Okay, so it's more of integrator than a designer, than an architect. That's why I said in the beginning that it doesn't really make much difference if it's going to be an architect, if it's going to be a senior developer. It just has to be someone who got their finger on the pulse of the queue.
But it is a member of the dev team.
It could be a PM. Okay, we have some that are PMs, right? So reactions from product teams. What? And these basically come from those people who would say in the beginning, go away and take your threat modeling every story away and don't bother me. These are people who, from the beginning, doesn't matter what you would bring to them, they would not understand why or what. And those are the ones that you have to take by the hand and go through the whole spiel and say, listen, at the end of the day, it's going to be good for you. Then we have, this is still too heavy. Oh well, that we're going to jump because I don't have time. Then we have, but how do I know I did everything? And that's a very valid question. Just think about that one. But again, and then there was this one that warmed my heart when I presented this in an internal forum that was only architects. And later on, I got to hear somebody say, I have never seen a room full of architects excited about threat modeling before. Now, this is not perfect. Okay? It is very hard to convince the teams that the subject list and even the checklist itself, that they are not extensive and all-encompassing. You still have to drill in their heads, listen, this is a starting point. I'm giving you a leg up. I'm not giving you the whole thing. The resulting threat model, nothing says that it's going to be perfect. Okay, so that question that was here. You have to look at it as an evolutionary process. If it is better than what you had yesterday, good for you. Tomorrow is going to be even better. But they're not going to be perfect just because of the methodology that you're using. And yes, you still need a security group or an SME that's going to be there going to see how the team is progressing and walk those hurdles so that they keep progressing. And of course, very important, a threat model is only as good as whatever you put inside. Okay, garbage in, garbage out. If you deal with having good input, you're probably going to get good output. So, about those two things, and just to zip through this because of the time, there are some parts of any threat modeling process that automatically, that naturally give themselves to automation. And those would be diagramming, the reporting, even the threat ranking, and finding some low-hanging fruit. And the reason why I call it low-hanging fruit is obvious. What we are interested in is what makes this threat model different from all others. Those things that are common to all of them, we can list based on attributes. Now, the important thing for me is that tooling, one of the big attributes of the tool is that it has to facilitate discussion. It has to make it easy for the team, for different people in the team even, because remember, not everybody in one given team uses the same platform even. Okay? So I needed to make it easy to discuss the system, to keep the model as close as possible to the reality of the system, so it has to be something that's easy to update, and it has to be something that's easy to distribute, so that I can make sure that the people who need access to that information to validate or to learn from it, have it. So what we have available today, there's a lot of threat model tools out there, and there's a lot of approaches, and there's lots of different target publics for each one of them. But some are very platform dependent, like the Microsoft tool. Others are web-based, and with that they try to solve the collaboration issue. Some of them, they start with a questionnaire that asks, hey, what is it that you're building? And then they give you a list of requirements at the end that you're going to give to your developers and hope that eventually they look at it. And others will have some kind of formal description of the system and look at that formal description and from it derive a threat model or generate threats based on those attributes. But the thing is that developers write code, okay? And I am yet to find a developer that likes jumping from Eclipse to Visio, okay? Dragging and dropping for some people, me included, is not a natural operation. But the thing is that, my personal opinion, I could be completely wrong here, but I think that threat modeling as code nowadays is in the same place that DevOps was a couple of years, okay? Everybody's talking about the thing. Everybody's talking about threat modeling as code, but we can't agree what it is. So we have awareness to the fact that it's interesting. We may be wanting to do this thing, but it's very difficult to agree between ourselves what is it that we mean when we talk about that. So there are three current practical approaches that I see popping up here. Well, actually two that I see popping up here and there, and one that's running from behind. Threat Spec, Threat Playbook, and PyTM. So now these are my definitions of what they're doing and how I see them doing. And both Fraser and Abhay were very gracious in listening to my rant on that and allowing or disallowing my understanding of their tools. But Threat Spec, for example, who does threat modeling in code, to me means that the threat modeling happens as code is written, and it mixes with the code. So we are encapsulating the problem and the solution as comments in code. And a lot of stuff, a lot of information can be extracted from there. A lot of good stuff can come from there. Now, Threat Playbook, my opinion again, is deriving previously identified threats from other tools, validating or discovering those threats present in code, and providing a proper language to talk about these threats. So build a library of threats, run your tools, marry those findings with the threats that you built before, and now you have a common language that you can use to talk about things. And then PyTM is threat modeling with code. So we are using code to express the system to be modeled and derive as much information from it as we can. Four main contributors nowadays to PyTM: Nick, Rohit, myself. So if you want to know more about it, you can catch each one of us, and Matt that couldn't be here. So this is what a bare bones threat model looks in PyTM. It's basically, you are going to write a Python script. Nothing different from any number of thousands and tens of thousands of Python scripts out there. You are just going to import from PyTM some different elements, different objects. You're going to create a threat model object, and you're going to call TM process. That's all. But that doesn't give us much, right? So using those elements that you imported, you're going to annotate those elements, create instances and annotate those instances, using characteristics like, is this server hardened? Yes. What's the operating system that's running there? Or this Lambda, does it have access control? Yes. Is it inside some specific threat boundary? Yes. So this is just a snapshot of the sample threat model that we have in the repository. The whole thing is something like 4 times this. So not a lot of code needed. And what we can do with that is once we wrote that script and run it, so we are running the same basic script that we wrote, we are passing it through dot, getting the output, and ImageCat is just some item2 thing to show the graph. So basically what you get from that script is already a DFD. Commented, trust boundaries in place, everything in there. Now, if you run exactly the same script, but instead now of a DFD, you ask for, a sequence diagram. Instead of dot, we run it through plant.uml. So using the same script, we get a sequence diagram now. So you can even use it for your protocols themselves. Right now, the system knows these threats. So right now we have a library of, I believe, 31 threats. Each one of them is basically one line of Python. Very easy to extend, very easy to add. We have a very basic report template where you can write things that relate directly to your data and use that to generate reports. So you ask for a report using that template, run it through Pandoc to get whatever output you want, HTML, Markdown, even Word. And what you get is something like this. So the way that it's being used right now, even in its very starting and limited phase, it's very easy to sit down in a meeting and start writing the script as people describe the system to you. And then you can use that script to look at it and say, okay, what's missing from here? What didn't I get? Generate the initial report. Bang, you have your baseline threat model. Now just improve on that thing. We also have people keeping the Python scripts that they write together with the code that's described by that script in the repository. And now if you see that the code is going somewhere, but the script is not, probably you just lost synchronicity between the code and the system that it's describing. We are inviting people, it's on GitHub, we are inviting people to collaborate with us. We are looking for more threats, more elements. We need to write documentation at some point. We have a very basic rule engine. We are looking to get something a bit more elaborate. And especially, we are very interested in integrating with other tools. I think that a natural first step would be to integrate with Threat Spec and Threat Playbook. And seriously, if people think that they don't want to write code or to contribute at that level, people with suggestions, bugs that we have to fix, requirements, some use case that we didn't think about, we would love to hear about it so that we can keep developing it further. Yep. Okay. So first of all, don't forget to leave feedback on the talk. That's very useful for everybody. And we had some questions going through, but if anybody has questions now.
So can we go back to the slides
So
now maybe?
that's the second reason why we decided to go with Python as the input language. Because
So deliberately for use in like build pipelines?
not really. The first one is that developers write code.
Yeah.
This for them could be Python, could be Java, could be whatever. The object-oriented paradigm is very easy to relate to. The second is that because it's Python, people could do whatever they wanted. So what you're describing, for example, I think that it's one of the base points of the threat playbook. For example, they have a huge and beautiful infrastructure to do exactly that.
Are there any particular?
But PyTM could do it.
Are there any particularly obvious challenges that you, or since Nick is here, Nick, might see with the pattern that I just described?
No. There is one, but it's more of a personal bias than a problem. What you would be doing would not be threat modeling. What you are doing is you're validating a template of tests. So there are other tools that could do that much better than PyTM.
Yeah.
But there's no reason why PyTM couldn't relate to them to use them to validate the assertion that you did at threat modeling time. So I'm not saying, no, you're not hardened. I'm saying you promised me that you would be hardened at threat model time, and you're not following that promise.
Yeah.
So it's a difference. To me, it's a difference on how you look at things rather than what you actually do it.
I'd love to continue this conversation offline.
Sure, sure. Anybody else? No, I have a wrap up here. They're going to, in the pool. So, anything, anybody?
I have one question, super easy. If you write code, then you will read it in order to review what has been done. So what is the usage of having drafts and generating drafts if it's not in the code, right? Because the problem I see with that is that, well, then you will have the graph, and then is it the, let's say, Plan QML stuff because we don't do it, or we'll change the graph, then we have to go back. So what do you think about?
So the way that we are seeing people use it is, first of all, the graphs are good for people who don't read code, and there's a lot of them. And the fact that the graphs get updated as the code changes, and you put that as part of your CI/CD, and you end up generating together with all the outputs of that CI/CD this threat model thing too, gives more visibility to it. People are more willing to pay attention to it because, after all, everybody wants to know what comes out from CI/CD. So it goes both ways. People who like code get the code. People who don't, they get the information that they need.
So it's attention grabbing and this kind.
It's attention grabbing. It helps sell it up to the office upstairs.
Okay. Thank you.
Anything else? Anyone? Nope. Adam.
So just to build on that a little bit is valuable.
Yep. Which I believe makes easier later on to apply the soft skills that you pointed to, right? Because we are building this mental image together. We are building this language together. It's much easier to talk about the same thing. You won't spend as much energy trying to agree on something that by definition is already agreed upon. Okay. Thanks, everyone. It's fun.